Question 6. Some researchers have conjectured that stem pitting disease in peach tree seedlings might be controlled with weed and soil treatment. An experiment was conducted to compare peach tree seedling growth with soil and weeds treated with one of two herbicides. In a field containing 20 seedlings, 10 were randomly selected from throughout the field and assigned to receive herbicide A. The remaining 10 seedlings were to receive herbicide B. Soil and weeds for each seedling were treated with the appropriate herbicide, and at the end of the study period, the height in centimeters was recorded for each seedling. A box plot of each dataset showed no indication of non-normality. The following results were obtained. All right, so we've got the sample means, x bar, and the standard deviations. All right, suppose we wish to determine if there was a significant difference in mean height for the seedlings treated with the different herbicides. Based on our data, which are the following, is the value of the test statistic. All right, so to find the test statistic, right, we would do t equals, x bar 1 minus x bar 2 minus mu 1 minus mu 2 divided by the square root of blah, 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 blah. But that'd be a lot of work, and since this is a multiple choice question, right, let's just take advantage of the functions on the calculator. So the calculator can help us because it has the function toSample. I think it's just called toSamp t-test. Okay. All right, so let's call herbicide A, that's going to be group 1. Herbicide B is going to be group 2. Right, we've got the means. The sample sizes were 10 each. Right. Okay, I think we can start entering in the data. So to find this function, you're going to press stat on your calculator, go to the test menu, scroll down. toSamp t-test is option 4 on my screen. It's probably on yours too. All right, so for stats, we have x bar 1, so 94.5. SX1, 10, N1, 10, X bar 2, 109.1, SX2, 9, N2, 10. All right, the alternative hypothesis, because we're looking for a difference, it doesn't specify whether one herbicide would have a greater mean or a lower mean. So I'm choosing the not equal to sign. Okay, pooled, leave it on no, and then calculate. All right. So this function gives a test statistic of negative 3.431733, etc. Okay. Now, looking at the answer choices, they're all positive, and so why did the calculator give me a negative test statistic? Okay. It has to do with the choice that I made here, right? I chose herbicide A as group 1 and herbicide B as group 2. So obviously when we subtract, we're going to get a negative value. Okay. Had we made a different choice, had we chosen herbicide B as group 1 and herbicide A as group 2, then when we subtract, we would have gotten a positive value, and then our test statistic would have come out positive. So it's just based on the choice that you choose for subtraction, like which is group 1 and group 2. All right, so C is going to be the